Hello, this is Frank Allen's chemistry lecture series for Davis High School's chemistry class. This is a lecture from Unit 4, and it covers the big idea, the basic principles of IMFs. IMFs is simply an abbreviation for intermolecular forces of attraction. These are forces of attraction that occur between molecules. The prefix inter means between. So if you think like an interstate, it runs between states or it connects states. Intermolecular forces of attraction are forces that connect or cause molecules to be connected. One way to think of it is to think of it as magnets. You all worked with magnets before, and if you take the two sides of different magnets that are oppositely charged, they are attracted to each other. Okay? So if this is a molecule right here and this is a separate molecule right here, they'll be attracted to each other based on these intermolecular forces of attraction. Now the intermolecular forces of attraction, they can be very strong or they can be very weak. It depends on how positive and negative the molecules are. This represents a molecule. You got a negative end and a positive end, and if you have a bunch of these molecules next to each other, they will align themselves so that the positives end and the negative ends are next to each other. And this is your IMF, the intermolecular force of attraction. Now this can be a really weak IMF or it can be a really strong IMF, and that depends on how positive and negative those ends or those sides of the molecules are. So if you think back to the magnet, if you have a magnet that is extremely positive and negative, it will be very strongly attracted to the opposite end of another magnet. So these IMFs, they can be very weak or they can be pretty strong. IMFs depend on how positive or negative the ends or sides of the molecules are. Stronger IMFs create higher melting points and boiling points, because when we melt something or when we boil it, all we're doing is giving this molecule enough energy to move around and leave this molecule and quit being the neighbor of this molecule. So when you go from a solid to a liquid to a gas, you're simply changing the amount of energy that these molecules have and enabling them to move more and move faster and go from a solid to a liquid or a liquid to a gas. Now there are many different kinds of IMFs. We're going to sort of just cover the basics of it, and so we've kind of simplified it. And you have to learn how to recognize these IMFs. There are 4 basic IMFs that you're responsible for learning here in this class. And again, these are not the most accurate descriptions of them, so if you're another chemistry teacher or a grad student, don't be alarmed. We're just simplifying things. We have what are called ionic IMFs. These always occur when you have a compound made up of a metal and a nonmetal. These are the strongest, and these are very positive and negative ends. So ionic IMFs may occur when you have a compound made up of a metal and a nonmetal. And if you remember from the periodic table, basically all the metals are on the left side and all the nonmetals are on the right side, with the exception of hydrogen. It's a nonmetal. It's hard to see that on the screen, I know, but you've heard this before in IPC. Now there are 3 types of covalent compounds, and these have weaker IMFs than ionic IMFs. There are some covalent compounds that give us hydrogen forces, and a covalent compound occurs when you have 2 nonmetals joined together. So if your covalent compound has hydrogen attached to N or hydrogen attached to O, nitrogen and oxygen, you have hydrogen forces. And these are still fairly positive and negative, but they're not quite as negative as the ionic forces. Polar covalent compounds, okay? It's really proper to say a polar force. This occurs when you have covalent compounds, and this occurs if the outside atoms are not alike or if you have lone electrons on the central atom, and you would know this by drawing the Lewis structure. Nonpolar forces. These occur when the outside atoms are all alike and you have no lone electrons on the central atom. So here is an or, here is an and. You have to have both of these. Here you can have either one. And polar is simply a word that means that it is not symmetrical, the sides are uneven or not similar, completely similar to the other sides. Social issues and political issues are sometimes referred to as polarizing issues because you have extreme sides with not much in the middle. So the word polar and nonpolar, look it up on Google and just kind of get a feel for what the word means. Now you have to be able to recognize which forces exist in a compound. If it's an ionic compound, if it has a metal, it's ionic, you won't need to draw the Lewis structure. You know automatically that there are ionic forces. If it's a covalent compound, two nonmetals, then you do need to draw the Lewis structure. Now most of the time I'm going to give you the Lewis structure for a question that asks you about the intermolecular forces. So I would encourage you to pause right now, look at this one, this one, this one, this one, this one, and at the rules we just covered, and then come back and check. But water is considered polar because you have lone electrons on the middle atom. That makes it very polar. And you also have hydrogen forces because you have hydrogen bonded to an oxygen. So you have two types of intermolecular forces here. NH3, you would have to draw the Lewis structure, and it's going to look like this. Now, although all of the outside atoms are the same, you have lone electrons on the middle atom, so that makes this compound polar. CH4, you draw the Lewis structure, it looks like this. All of the outside atoms are the same. There are no lone electrons on the middle, so this one is non-polar. If we replace one of the hydrogen atoms with a chlorine atom, this becomes polar because the outside atoms are not all alike. Here, this is carbon dioxide. We worked with this in class, dry ice. It's a gas at room temperature. It's non-polar. No electrons on the middle atom. Outside atoms are the same. So these are going to have the weakest intermolecular forces, and they will have the lowest melting and boiling points. This has the strongest intermolecular forces, and it will have the highest melting point and boiling point. And then these will be dispersed somewhere in between, although because this one has both polar and hydrogen forces, it will have stronger intermolecular forces than these, and the melting point and the boiling point will be higher because these two together are stronger than these two alone. If you have any more other questions about IMFs, see me after class.